true is true. So I figured out this side is true. Over here, not H. H is true, so not H is false. Now let's go inside the brackets. I then J, false. Oh, I'm looking at the wrong line. False then true is true, and so false or true is true, and true if and only if true is true. So line 3 is true as well. Okay. So now line 4, H is true, I and J are false. So H is true, I and J are false. So false then false is true. And so I'm doing true then true, which is true. So the left-hand side of the biconditional is true. Let's go over here, not H. H is true, so not H is false. Okay, now I need to do the I then J, and it's false then false, which is true. And so then I do false or true, which is true. So I calculated this side of the biconditional, and so I'm left with true if and only if true, which is true. Okay, halfway there. Okay. This line, H is false. Now, H is false the rest of the way down, right? False, then anything is true. Does everybody understand that? Think about it. False, then true is true, and false, then false is true. So I know I'm just dealing with this side of the biconditional. I know the antecedent is false on this conditional. Do I need to calculate all that stuff? I don't. Since I know the antecedent is false, I know that this conditional for 5, 6, 7, and 8 is true. Everybody understand that? I'm taking a shortcut, right? Over here, H, remember H is false on 5, 6, 7, and 8. So not H would be what? True, 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 and true. And now notice what we're doing, true or. Now look at the true over there. What does it take for an or to be true? One disjunct. It only takes one disjunct being true, and the whole thing is true. Does everybody get that? And so I know the first part is true. True or anything is going to be what? True. So I don't have to do all those calculations because we're smarter than that. Since we know that this disjunct is true, the whole disjunction must be true. And now look, true if and only if true is true. There we go. Okay, so this statement came out true in each and every possible combination of truth values for the statement constants. So what kind of a statement is this? Yes. Any questions about that? If it came out always false, we'd say it's self-contradictory. And if we had some truths and some falses, we would say that it is contingent. Everybody understand that? Okay. So that means you should be able to do whatever section that is. That was 3.3. Okay, 3.4 is, we are going to skip 3.4, okay? remember when we were doing the unknowns, I showed you a way to do it? And that technique works for very small expressions, but when you get really big ones with multiple unknowns, you have to adopt a different technique. And I don't think that's necessary for us to learn, just so long as you understand those little tricks that we learned in 3.2, okay? And 3.5, so we're skipping 3.4. 3.5, in 3.5, those labels, tautology, self-contradictory, and contingent are introduced. So it's the very same thing. You're just working the problems, calculating the truth values for all the different possible interpretations, and then based on the final column, under the main logical operator, if it's all truths, you just say tautology, all false, you say self-contradictory. If you have some true, some false, you say contingent. That's the only thing that's added to 3.5, just adding some labels, okay? All right, so that means you can do everything up to 3.5, okay? And instead of overfilling your brain when you still have a chapter test to do, that's where we're gonna stop today. Does everybody understand that? So your first duty is to get the chapter 2 test done, right? And you can download it as a Word doc or as a PDF. If you have trouble uploading it, remember the bailout is to what? Send it as an attachment. Send it as an email attachment to me. Remember, if you're highlighting to indicate answers, also indicate the answer some other way, because highlights don't always transfer through, have no idea why they work or don't work. And then also look, if you download the Word document and you open it up in your browser, you might not get the right symbols. So if you're getting symbols that don't match our symbols, what you need to do is download that document to the desktop and then open it from the desktop instead of in your browser. And sometimes that will clarify it so you're getting the right symbols. If the symbols are still gobbledygooky there, download the PDF to the desktop and that should work. Does everybody understand that? Okay. Any questions about chapter 2 or chapter 3? Yes?
I have a question. I saw one of the statements had like a double negation, and it was more physically asked to identify if it was
Well-formed formula or not? Okay.
and also if we can identify the main logical operator.
What?
And if we can also identify the main.
Yeah, right. So look, you know that you can't have stuff like this, S or then F, because you have two operators, right? Okay. The one exception to that is negation. You can have that, this, and you can have that. That's still a well-formed formula, right? Because we know we would negate the S and then we would negate the S. And there's no difference between this and that. Does everybody understand this? So if S is a well-formed formula, then not S is a well-formed formula, and not S is a well-formed formula. Okay? So don't let double negations mess you up. But notice that, look, if I had this, not S or F, what's the main logical operator?
Second negation outside.
This negation, yes. Right. Because we do this negation or F and then we negate the result. Everybody got that? So that one would be well formed, and we would say that the first negation is the main logical operator. Any other questions concerning the content of chapter 2? Yes?
Concerning not having two things at the same time. If, for example, the first statement says Harry Harry is the father of Tina, for example, and the other statement also says Tebow is the father of Tina,
So two people claim to be the father,
the father.
and the biological father, and they can't be both, right? So we know it's X or Y is the father, but we know that they both can't be, okay? So this is an inclusive OR, which would say X is the father or Y is the father, or they're both the father, but we know that that cannot be, right?
Yeah.
So what we have to do is we have to do this. It's either X or it's Y, but it's not X and Y. And now that tells us that's one or the other and not both.
At the same time.
Right. That's how you express an exclusive OR. So if you need to say this OR is exclusive, you need to add that and not both. Everybody understand that? Right. If anyone misses this problem about kings, you're in trouble. Okay. Any questions? Any further questions? Yes.
What, like the block parentheses versus the kind of,
Yeah. What about
like, when do you add the kind of,
you don't there's no logical difference between this or even this. Does everybody understand that? The convention, and the reason why I might go to this is just for ease of seeing what goes with what. Does everybody understand that? And the convention is that these are innermost, and then those are outer, and then those are right. So if you did something like this, people would really hate you, right? But technically it's not wrong, right? A compiler would see those as the same, right? Any other questions?